All right. Good morning and welcome to Masatoka online class. In today's video, we'll be talking about light wave. I've done our first video on light wave where we talk about pinhole camera. But in this video, we're talking about reflection of light. Okay. Now, first of all, what is reflection? Now, reflection of light is defined as the process whereby incident ray is thrown back on meeting a barrier. Incident ray is thrown back on meeting a barrier. For example, now, if you flash a torch on a wall, okay, you notice that the light does not penetrate through that wall. What happens? It bounces back. Okay, so if you have something like this, whether it is a rough plane or a smooth plane, as far as you have a plane like this, and then let me say that this is my normal, and then there is a force, there's a source of light coming this way, which is called the incident ray. This is the incident, the one coming that will hit this surface is called the incident. Then it will bounce back. This bouncing back is what we call the what? The reflection. Okay, so reflection um, uh, is simply the process whereby the incident ray bounces back on hitting a barrier. All right, now we have different types of reflection. The first one is the regular one and the irregular one. Okay, the regular reflection and the irregular reflection. Now the regular one simply means uh, uh, now in the regular the regular reflection simply means the reflection whereby we have a smooth plane. Okay, if it's a smooth plane, then it is a regular one. Okay, so regular reflection, this is the type of reflection that obeys the law of reflection. Yes, it obeys the law of reflection as well. Why? Because if you have this is my normal, that the incident ray, this one coming this way, bounces back, and once they bounce back, the angle of incident is always equal to the angle of reflection. Then we conclude that this is what a plane or a regular uh, object, okay, or mirror, okay, or a regular barrier, something like that. Okay, now, but for number two is that if it's irregular, if it's irregular, it cannot be smooth like this. It could be a rough plane. For example, that wall, I gave you an instance. Now, if I have my normal like this, for instance, now the incident ray coming here, okay, once they bounce to this place, it does not move at equal, you understand, it could just bounce this way. You now see that here is not equal to here, so it does not obey the law of reflection. Okay, so that is when you call it what? An irregular reflection. Okay, so it does not obey. So that is that. Then the next one we'll talk about is the law of reflection. Now the law of reflection, they are just two. Okay, the first one states that when you have a plane mirror like this, they say that the incident rail, they say the normal, the incident rail and the reflected rail all lie on the same plane. Okay, the incident rail, which is the one coming, I can decide to say that this one is the one coming, then this is how it bounces back. So the first law states that what? Both the incident rail, the normal and the reflected rail all lie on the same plane. That is number one. Then number two now say that what? The angle of reflection is equal to the angle of incident. Okay, the angle of incident is the angle the incident ray makes with the normal and not with the plane. Okay, this one is called angle of incident because it is one coming in, and the one coming in is called incident, and the one moving out is called the reflection. So the angle of reflection is equal to the what? The angle of incident. That is the second law of reflection. And don't forget that this law holds for what? A plane mirror. or a regular surface. The surface must be smooth and regular. If it is not smooth and regular, this one, the second law will not work. But the first law works, where the normal, the incident, the reflected, they all lie on the same plane. Okay, so that is that. So the next thing we'll talk about is definition of terms. So let us define some terms. The first thing we're going to define is the incident rail. The incident rail, this is the ray of light that is falling on the surface of the mirror. Like I told you, the one that will fall, the one that will come in, the one that will come in and bounce on that mirror is called, or that hit on that mirror is called the incident ray. Okay. Now the reflected ray, this is the ray of light that is thrown back on striking the surface of the mirror. I've told you that already. Okay. That incident comes in, then the one that bounces back is called the reflected brain. Okay, the next one is what? The angle of incident. I've told you what angle of incident is. Angle of incident is the angle the incident ray makes with the normal. Okay, the next one is the normal. The normal is a normal is a surface. A normal to a surface is a line drawn in such a way that it is perpendicular to the angle of it is perpendicular to the surface. Like I told you that this is it. If you have a smooth surface, then the normal is always perpendicular or meet at angle 90 with what? With the surface. So the next one we'll talk about is what? They say note the angle of incident, the angle between the incident ray and the normal is called the incidence. Okay, and not the incident or incidented angle otherwise. Okay, the angle of reflection is not called the reflected angle. Hmm. Okay. Okay, it's called the angle of incidence, not incident. Okay, that one is just grammar, right? Okay, so we'll talk about glance. Okay, glance is the angle the incident ray or the reflected ray makes with the horizontal plane, makes with the plane. I have that this is my reflected ray and this is my incident ray. Okay, and this particular angle it makes with the horizontal or the plane is called my glance. This one is going out, so this is the glance of reflection. This one is coming in. Okay, so this one should come in. The other one is going out. This one is coming. This is called the incident glance. Okay, so you should notice that if the angle of incidence is always equal to the angle of reflection, then therefore gi, the angle of the glance of incidence must be equal to this one. Okay, they must be equal as well. So that is it. So let us take some example. They say that the angle of glance G. This is the angle which the incident ray or the reflected ray, as the case may be, makes with the plane of the mirror. Then I say that as incident ray, incident angle is equal to the reflected angle, then the angle of glance in both sides are equal, where GR is the glancing angle of incidence and GR is the glancing angle of reflection. Okay, example. So let us solve questions. You know, uh, my YouTube channel brings you about calculation on physics and chemistry with mathematics, right? So please, if today is your first day of watching my video, please click that red subscribe button so that YouTube will always notify you anytime we drop a nice video like this. And then give this video a like and a comment so that YouTube can recommend it to other people. Okay, so the first question here, question number one said a ray of light a ray of light is incident on a plane mirror incident on a plane mirror at an angle at an angle 30 degrees to the normal. The- to the normal. They say determine I the angle of reflection I the angle of glance. Okay. Solution. Now, even if you decide not to draw it, but let us draw it. If you decide not to draw it, you will still get your answer. But let's just draw it for me to just explain. This is my normal. Okay. That's that a ray of light is incidented on a plane mirror at an angle of 30 degrees to the normal. So let me say that this one is the one coming in. This is that incident ray coming in. Okay. And they say that the angle it makes with the normal is 30 degrees. And I told you something that this is the reflected ray, and since it's a premilo, that this is going to be the what, the reflected what, ray, and that reflected ray must be equal to the incident ray. So here it's set as 30 degrees. Tell them that what, the reflected angle is equal to the what, the incident angle, so which is equal to what, 30 degrees. Now for the glance, this is my glance, the glance of the incidence and the glance of the reflection. So this one coming in, this is the incidence, this is the reflection. Okay. Now don't forget that this is a straight line. You can use angle on a straight line, and don't forget that gi is always equal to gr. So we can just say that what, that gi plus my incidence angle, okay, plus my reflected angle plus my uh, glance of reflection is equal to what, 180 degrees. What is your reason? Sum of angles on a straight line. Sum of angles on a straight line. So sum of angles on a straight line. So if you now put everybody, you'll be having that your gi, my gi, let me just call it g, is equal to what? Let me say that all this is equal to just a g. Sorry, my gi, that is my g plus this one is 30 already. I've equally gotten this one as 30 plus this one is still g is equal to 180. So g plus g will give you 2g. So 2g plus 60 is equal to what? 180. So what do we have? We now have that 2g is equal to 180 minus 60. So 2g is equal to 120. So my g is equal to 120 divided by 2. So my g is equal to what? 60 degrees. So that is that or that. We'll go to the second question. Okay. Now let's move to the characteristics of image formed by a plane mirror. The characteristics of image formed by a plane mirror. Now, if you have seen, if you have watched, if you have looked, if you have seen a plane mirror before, like you want to see yourself on a mirror, if you observe what happened, try to do something with your right hand, looking at the mirror. You will see that your right hand appears to be like a left hand. Okay, so that is one characteristics of a plane mirror. So the first one, so let us just read it out. It said that the image is what? Visual. Yes, it is visual. You will see it very well, clear. So they say this is because it is formed behind the mirror or formed by visual or apparent interception of rays. Okay. Number two, they say that the image is upright. That is erect. Yes, the image is erect. It's not inverted. It is erect. Okay. So number three, the image height is equal to the object height, or the image distance is equal to the object distance. Okay. The image height is equal to the object height, and then the image distance is equal to the object distance. So the height of that image If you look at yourself in the mirror, your height normally is equal to the height you are seeing in that mirror. Okay. Eh, and the more you move further, maybe you move backward, you see that the distance from your mirror to yourself is equal to the distance from the one you are seeing inside the mirror. Okay. So you can do the experiment by moving forward and moving backward. See that the image is equally moving as you're moving as well. Okay. So that is that. So therefore, magnification is equal to 1. So note that in a plane mirror, magnification is equal to 1. We did magnification in our former video. That is in pinhole camera. Did magnification. Okay, so you can watch the video to understand better. The magnification is simply the image distance over the object distance, or the image height over the object height. So since they are equal, anything divided by itself is 1. So in a plane mirror, the magnification is 1. So in other words, the image is far behind the mirror in objects. Sorry, you see that, in other words, the image is far behind the mirror as object is in the front. You see that the image is literally inverted. Yes, the image is what? Literally inverted. Literally inverted we mean is that your left hand looks as if it is your right hand, and your right hand looks as if it is your left hand. Okay, so that is that. And next one is uses of plane mirror. You know the uses of plane mirror. The use of plane mirror, you can read up that it is used at home. It is used in your in that mirror you are seeing inside the car, not the one we are using by the side of the car. The one inside the car is a plane mirror. Okay, it is used in a simple periscope and a simple caridoscope. Okay, is equally used in a sextant. Say note, a simple periscope is formed when two plane mirrors in are inclined at an angle of 45 degrees. It is an example question they can ask you that. How do we form a periscope? Okay, a periscope is formed when two mirrors are placed at an angle of 45 degrees to each other, while a caridoscope is formed when it is placed at an angle of 60 degrees to each other. So don't forget, the first one is 45, while the second one is 60 degrees. A sextant is used to determine the elevation or the altitude of the sun. Okay, then I say angle of deviation of a plane mirror. Angle of deviation of a plane mirror. That is the next thing we'll talk about. So let me check my time. Okay, so the angle of deviation of a plane mirror. Now, if you have a plane mirror that is like this, have a plane mirror like this. Is a plane mirror. Then this is my normal. This is my normal. Okay. Now, if we have the incident ray coming this way, okay, let's assume that it continues. It continues. Don't forget that the reflected ray will go this way. Now, the angle from here to here is what we call uh, the angle of deviation. Okay, this is what we call the angle of deviation. So the deviation of uh, original incident ray. So this is the angle of deviation. Let's call it capital letter D. So that is what we call the angle of deviation. This is that the angle of deviation D of a plane mirror is the angle uh, between the direction of the original incident ray and the reflected ray. Note that D is equal to 2G, where D degree is the angle of deviation. So, okay, so they say that now, look at another thing you need to know. Do you know that that here is G? Don't forget that here is G. And don't forget that here is equally G. If here is equally G, don't forget that this is opposite to this place. Okay, this is called vertically opposite angles. So here is equal to G again. That is why we say that what angle of deviation is equal to what 2G. Okay, 2 angle of glance. Yes. So if you double angle of glance, you get your angle of deviation. So don't forget about that. The angle of deviation is equal to 2G. So if you want to make calculation with deviation, if they give you calculation with deviation, just know that instead of writing G and another G, then you will just say that this angle on a straight line from here to here is an angle on a straight line, and here is equal to your what? This one coming in. This is the incident I, and this is your reflection R. Okay, you will now see that your R plus your I plus your D here plus here, then plus the last one will give you angle on a straight line. So sorry, plus your D is equal to what? 180 degrees. So sum of angles in a straight or on a straight line rather. Okay, so the next one we'll talk about is the effect of rotation of a plane mirror. The effect of rotation of a plane mirror. So that is the next one we'll talk about. The effect. We have not started calculation. We're just explaining one or two things. The effect of what? Rotation of a plane mirror. If you rotate a plane mirror, what happens? That is what we want to talk about now. We have a plane mirror that is like this. This is a plane mirror. And then this is my normal. Okay. Then now we decide to rotate this mirror like this. We decide to rotate this mirror. Okay, what happens when we rotate the mirror? To rotate the mirror, you will see that we'll be having that uh, this one standing like this will now be here. Okay, so why the normal here, the normal now will now turn to the incident rail. Okay, then we'll now have the reflected rail. Let's say that we have the reflected rail somewhere here. Okay, so description: when a plane mirror is rotated through an angle theta, okay, the reflection rail is rotated through twice the angle of which the mirror is reflected. Twice the angle of which the mirror is reflected. Note, the incident rail remains constant. Okay, the incident rail remains constant or the same along the path as the plane mirror is rotated through position 1 to position 2. They say that if the mirror is rotated through an angle of 15 degrees, then the incident rail is rotated through an angle of 2 times 15. So, you should know that so if a mirror is rotated through an angle theta, then the reflected rail is rotated twice. Okay, the reflected rail is rotated twice of it. So it's a very, very important statement to note. It's a very, very important statement to note. So let us solve a question to illustrate what we just said now. So the first question we're going to solve here said a rail, a ray of light, a ray of light is incidented on a plane mirror incidented on a plane such that the angle of reflection, the angle of reflection is 25 degrees. Now say what what is the angle of deviation? What is the angle of deviation of the rail? What is the angle of deviation of the rail after 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 reflection from the mirror? After reflection from the mirror. Okay, it's a very simple statement. So we have already been told that solution, you don't need to draw it anyways, but if you want to draw it, no problem. But we already told that the angle of reflection, our r degree, is equal to our I degree. Angle of reflection is always equal to the angle of incidence, which they say is equal to 25 degrees. And don't forget I told you that if you want to put deviation, that deviation is equal to what? 2g. So we should know that what that our r degree plus our I degree plus our d is equal to what? 180, because it's supposed to be plus g of this and g of this. I hope you know. Normally, this is how it's supposed to be. This is how it's supposed to be. It's supposed to be your r degrees. It's supposed to be your what? Your r degrees plus your I degrees plus your g of I degrees plus your g of r degrees is equal to 180. This is how it's supposed to be. But these two people now is equal to d. So we have that our r degree plus your I degree plus your d is equal to 180. So therefore I have that 25 plus 25 plus d is equal to 180. So finally we'll be having that 50 plus your d is equal to 180. So therefore my d will now be 180 minus 50, which is equal to what? 130 degrees. So if you divide it by 2, you will now get your your angle of glance. Okay, so that is that. So the next one we'll talk about is what? Image produced on an incidented plane. The image produced, so that's the next thing we'll talk about. Image produced, uh, image produced on an incidented plane. Image is produced. Let me refill this mark. Image is produced on an incidented plane. Okay. So image is produced on an incidented plane. Okay. Now they don't say that a given number of images are produced when two plane mirrors are inclined at an angle of theta to each other. So the formula we use that what? The number of images produced is simply equal to what? 360 degrees over that angle, then minus 1. Very simple. 360 degrees divided by that number of angle minus 1. As simple as that. So anyone you want to find, you can easily find that. So let us solve question to illustrate that. The first question we'll solve say that what? An an object an object 1.5 meter high, an object 1.5 meter high is placed 30 cm in front of a mirror, comma. That's a calculate I, the height of the image formed, II, the distance between the object and its image. Okay. Now don't forget that now we told you that in a plane mirror, the magnification is equal to 1. And if magnification is equal to 1, it shows that uh, image height, the image height, let me call it hi, the image height must be equal to the object height ho. So and they say that an object of 1.2 meter high, so is equal to 1.2 meter. Very simple. And then you should know that image distance must be equal to what? Object distance. And we they told us that it is equal to what? 30 cm. 30 cm is something as 0.3 meters. So as simple as that. Okay, but they say that since the image of an object formed by a plane mirror is far behind the mirror as the object is in front of the mirror, we say that v is equal to u. Okay, then the distance between the object and the image. Okay, now this one is what we got is what the image distance, and you know that they are equal. So but what they are asking us is now is that the distance between the object and the image, okay, and not the mirror. Let me tell you something now. Look at what we are saying. If this is the mirror and then I am the one standing here, if I'm standing here, this is me standing here. Okay, this is me standing here. From here to here is the distance between me and the mirror. Okay, and that is called the object distance. This is the object distance. Then I am formed on the mirror here on the same distance from here to here, the same distance, which is called the what? The image distance. So they're now asking me what is the distance between the image and the object. So that is from here to here. So if here is 30 and here is 30, so the distance between the object, the distance between the object and the image formed, the image is equal to what? 30 plus 30, which is equal to what? 60 cm, which is 0.6 what? Meters. Okay, so that is what we are asked to find in that particular question. So we move to question number 2. So question number 2, let me check my time. Okay, I think we are going to stop here. Then in our next video, we'll just solve calculations. So that means we are going to repeat this question. So bye bye.